Math 20-3, we're doing compound interest. So, in this lesson, we're going to look at another type of interest, compound interest. Now, compound interest is interest calculated on the principal amount plus the interest earned. And in compound interest, interest can be paid more than once a year. Now, in general, interest is stated as a percentage per annum and is divided by the number of compounding periods, okay? So it's the number of times the interest is paid per year. So we have to do a little more work with our formula before we can start. So for example, if the interest is compounded semi-annually, that would be 2 times per year, and we would divide the interest rate by 2. If it's compounded quarterly, it would be 4 times a year, so we would divide the interest rate by 4. If it's compounded monthly, there's 12 months a year, so 12 times a year, and we would divide the interest rate by 12. Daily, there are some situations where it's got daily compounding. Well, there are 365 days in a year, so we compound it 365 times a year, so we would divide the interest rate by 365. Okay, so we're going to start with a simple one, just an annual so we don't have to change the interest. We don't have to divide. So let's look. And this is similar to the one we did for simple interest, but now we're doing it with compounding. So we have an investment of $2,500, and it's going to grow over 5 years using compound interest. The interest rate is 5% compounded annually. So our opening balance is our principal, is $2,500. The interest rate was 5%, so that's equal to 0.05. We move the decimal place 2 steps to the left. The interest amount is still our principal times our interest. Oops, I added an extra 0, which is equal to $125. So our closing balance would be $2,500 plus $125, which is equal to $2,625. Okay, now this is a step where it's a little different. Now, year 2, we keep our closing balance from year 1 instead of going back to our initial principal. So now we have $2,625. Our interest rate is still 5%. So when we figure out the interest amount here, instead of doing 2,500 times 0.05, we're doing 2,625 times 0.05, which is equal to 131.25. Try that in your calculator if you don't believe me. Now our closing balance after the second year is 2,625 plus 131.25, okay, which is 2,756.25. Okay, now we carry that interest over. So what we're basically doing, if we look at this here, this interest gets carried over here, and now we're going to carry over this 2,756 over to the next opening balance. Okay, so we get to add that interest to our total. Our interest rate is still 0.025, so now we go 2,756.25 times 0.05, and we will get for our interest 137.81. Reading the wrong column. Now we add that to our opening balance, 2,756.25 plus 137.81, and that equals 2,894.06. Now, what balance are we going to carry over? We're going to carry over this 2,894 So that will be 2894.06. So what we see is our balance is growing a lot faster. Our interest rate is still 0.05. So we have 2894.06 times 0.05, and this equals 144.70. So not only is our balance growing, but also the amount of interest we earn each year is getting larger because it's based on our balance, our opening balance, and that's growing. So 2894.06 plus 144.70 equals 3,038.76. Now we're going to carry that over, and it's going to go there. 3038.76. Our interest rate is still 0.05. So we have 3038.76 times 0.05, which is equal to 151.94. So take 3038.76 plus 151.94, and we get 3190.70. Now, if you scroll back to when we did simple interest, we actually started with the same principal and our same interest rate. But at the end of it, we only had 3,125. So we earned more interest doing it with compound. Okay? So here, how much did we start with? $2,500. How much do we have at the end of 3 years? 3,190.70. How much interest did we earn? Well, if we take 3,190.70 and we subtract 2,500, we get 690.70. Okay? So that's how much money we earned in 5 years on our initial. Okay? Now our formula for compound interest is a little bit different than for simple interest. It looks like this. The amount, total amount, is equal to the principal times the interest rate as a decimal divided by the number of compounding periods per year. So this is significant. And you'll notice in the brackets it's 1 plus that I. And then n is the number of times compound. So it's the number of years times the number of compounding periods per year. I actually want to highlight this one a little differently. I want to highlight it this. And it just means something to me. Okay, so we have to do a little more manipulation to create our formula. But we can do it. I'm not worried. So let's look. Susan invested $4,000 at a rate of 8% compounded quarterly. So let's end this. We have this 8% compounded quarterly. What is the value at the end of the 2-year period? So let's, as I like to do, let's make a list of what we know. So we're looking for the amount, right? The principal is $4,000. The interest, well, okay, it's 8%, but it's compounded quarterly for 2 years. Now, first we're going to change it to a decimal, 0.08, and then we're going to compound it quarterly. So that means we divide by 4, because that means quarterly means 4 times, which is equal to 0.02. And then our n, our time, is the number of times compounded in total. Well, it's 4 times per year, but it's 2 years. So it's 8. So we've got everything we need to know here. We're going to put it in our formula. A is equal to P, 1 plus I to the n. So 4,000, we know that, times 1 plus 0.02 to the 8. Okay? 4,000 1.02 to the power of 8. And I put that in my calculator, and I get $4,686.64. Okay? And that's the total amount. Now, if I wanted to figure out how much interest, I would just subtract 4,000 from that. But it hasn't asked me to do that. It just wants the value of the investment. All right, let's do another one here. Marcus invested $1,000 at 6% interest, compounded monthly. Let's highlight some of this. $1,000 at 6% compounded monthly for the 10 years. What is the total amount of money at the end of 10 years? So we're looking for the amount. Our principal equals 1,000. Our interest rate equals 6%, which is 0.06, and it's compounded monthly. So we divide by 12, which equals 0.005. And N, well, it's compounded monthly, so that's 12 times a year and times 10 years. So 120. All right, so A is equal to P times 1 plus I to the N. Let's fill in what we know. P is 1,000. 1 plus 0.005 and to the 120. Let's add in the brackets 1.005 to the 120. Let's put that in our calculators and we get 1819.40. Okay. And again, if we wanted to figure out the interest, we could just subtract the initial amount invested. Okay. Example number 4. Jim invested $600 at a rate of 7% compounded semi-annually for 3 years. So here it wants the total amount of money in the account after 3 years. So let's figure that out. Let's write down what we know. A is what we're looking for. P is 600. I is 7% divided by, it's compounded semi-annually. So, well, actually, let's turn it into a decimal first, then divide it by, semi-annually means it's compounded twice. So we get 0.035. And then our N, compounded semi-annually, so twice a year times 3 years. So that would be 6. Let's fill this in. A is equal to P, 1 plus I to the N. We know P is 600. We have 1 plus 0.035 to the 6. 1.035 to the 6. Put that in our calculator. We get 737.55. Now the next question says, how much interest did he earn over the 3 years? So we take this value. So interest will equal the total minus the principal. So 737.55 minus 600, and that equals 137.55. So that's his interest. Okay. All right. Now, a couple more steps in simple interest. You got to do a little thinking about the number of compounding periods and that sort of thing, but you can do it. Okay. All righty. Example 5. Last example here. We have 2 questions here because we have Bank A and Bank B. So we're going to have 2 options here. I'm going to split it in half so I can separate my work. Bank A, and I'm going to highlight Bank A in green, offers an annual interest of 10% compounded annually. Bank B offers an interest rate of 7.5% compounded quarterly. Suppose you deposit $5,000 in each bank for 2 years. Which one will earn you more interest? So first we got to make our list, right? So Bank A A is equal to, we don't know. Principal is 5,000. Our interest is 10%, so that's 0.10 divided by, it's compounded annually. So we actually just divide it by 1. So that would be 0.1. Our number of compounding periods is, well, it's compounded annually times 2 years, so it'd be 2. So for here, A is equal to P1 plus I to the N. P is, 5,000 times 1 plus 0.1 to the 2. So 5,000 times 1.1 to the 2, which equals 6,050. Okay? So that's how much you would earn at Bank A. Bank B, well, let's see. Our amount is what we're looking for. Principal is the same. The interest rate is 7.5%, which compounded quarterly. So this would be 0.075. Quarterly means 4. So this would be 0.01875. And N equals, well, it's compounded quarterly, so 4 times a year times 2 years, which is 8. So A is equal to P times 1 plus I to the N. So we have 5,000 times 1 plus 0.01875 to the 8. So that's 5,000, 1.01875 to the 8, which equals 5,801.11. So looking at those, even though you compounded the second one more often, the first one had a higher interest rate and you ended up earning more interest. And I just want to double check something. Yep. Okay. So after all this, Bank A earned you more. Now it says, how much more interest do you earn? Well, you just take the 6,050 and you subtract the 5,801.11, and that's going to tell you the difference. So Bank A, you earn $248.89 more. All right, so that's compound interest. As you saw, it's a little bit different from simple interest. So now do some practice, and then we're going to look at it a little more later today.